So, this is lesson 5 in geometry. Okay. So basically, lines and planes are classified by how they intersect. So perpendicular lines. This is stuff you know. If I were to describe perpendicular lines, probably the first thing I would do is like do this or something. Not like this or this, but this, right? When they intersect, they form square corners. Okay, so lines intersect to form right angles. Okay, the sign for perpendicular is this upside down capital T. So whenever you see that written on the board, that's how I'm going to spell that, because this is a pain in the butt to spell perpendicular. So this is how I would say perpendicular lines.
Does this lesson have a typo?
More theorems about lines and planes. So if you want to take a look up here, we're just going to look at example 1. Lord willing. Okay.
Property and 2 roads.
That's property.
That's what it says.
Good reading.
Okay, so look at this cube here. So can you give me some examples of perpendicular lines? In this cube, in lesson 6.
Line AD and line DH.
All right, let's see if AD and DH are perpendicular.
And DC.
AD and DH or AD and DC. Okay, good. So those are perpendicular lines. What about AD and BF? What about AD and BF?
Perpendicular.
I mean, they can be.
I mean, yeah, it's weird, right? They're not on the same plane. So here's what you have to do. I have to add this, I have to do some of geometry's work here. And I have to add this line, this word in there. Coplanar lines intersect to form right angles. Okay, those are that's the definition of perpendicular lines. Okay, so they have to be on the same plane, otherwise they're called skew lines. Okay, skew. All right. Okay, so that's an example. Those are an example. What about coplanar lines that do not intersect? What's that called?
Parallel.
Yes. So what are some examples of some parallel lines on the cube?
ADEH.
ADBC.
AD and EH. Yeah, that's awesome.
Yeah, I agree with him a lot of them.
So these are parallel lines. Okay, so AD is parallel to EH. So the symbol for parallel that I use is some obnoxious lines like that. Make sure you over exaggerate how long you draw them, because if you don't, then it's going to look like this. And that's confusing, right? Make them obnoxious. Make them obnoxious when you do that. But you shouldn't have to spell parallel. You can just say that every time you want to say parallel.
Coplanar lines.
So those are parallel lines. Now, there's also such a thing as parallel planes. In this cube, can you tell me two parallel planes?
AEH and BCG.
Good job with 3 letters. AEH and
BCG.
BCG. So the front of the cube and the back of the cube. Very good. So remember, to label a plane, you need 3 non-collinear points. So see how they don't, A, E, and H are not on the same line, but they are on the same plane. And there's only one plane that contains AEH. It's that front of the cube. So these are planes that never intersect. And you don't have to say co-anything on this. Co-spatial, well, that doesn't even, everything's co-spatial. So you can just say planes that never intersect. Okay? Now, remember, planes go on forever in both directions. So even if that cube was a little dented in or whatever and it came like this, those would not be parallel planes because they would eventually intersect. But these, we can assume that these will never intersect. Okay? Because if it's a cube, that's what a cube does. All right, so far so good? Okay, there are such a thing as perpendicular planes. What's an example of perpendicular planes?
So would that be AEH and like ADH?
AEH and AD. So what'd you say? ABH? What'd you say?
ADH and then AEH?
AEH. So that would be the same plane. So
Cool.
see how ADH and A. So like you could say, if that was the front, you would have to either tell me the ceiling or the floor, right?
Or the sides.
So what'd you say? Or the sides, yeah. So ADH would be AEF would be perpendicular to that as well. Yep. Yeah. So planes that yeah, we'll talk about those in a second. Okay. All right, and then we talked about planes that form right angles. So skew lines, we talked about that. Skew lines are non-coplanar lines that never intersect. Skew lines are non-coplanar lines that never intersect. Okay, and really you can just say non-coplanar lines, because if two lines are intersect, they're always coplanar, because no matter how you draw it, they always form a plane. Okay, so you really don't need these non-coplanar lines. You don't really need those 3 words, because non-coplanar lines are always skew. Okay, so these are skew lines. And there's multiple ways to draw skew lines. Just don't do that, because look, they'll eventually intersect. Okay? Sorry, I didn't do that in front of the camera. Skew lines. Okay, got it.
How many people in this class are online?
Wow.
1 or 2, I think. I know that Caden is one of them. We love you, Caden. Good luck. Okay, so let's look at our first theorem. So this is theorem 5.1. Yes, more theorems.
I don't like
I don't mind them.
Whoa.
Does
Ouch.
anyone like them?
If 2 parallel lines are cut by a third. Oh, sorry, don't say lines. I got carried away because usually when you're talking about parallel, you're talking about lines. If two parallel planes are cut by a third plane, then the lines of intersection are also parallel. Okay, so in our example here is plane ADH is parallel to plane, what was it, BCG, right? The front and the back, right? So look at plane CDH. CDH cuts them. So where does CDH intersect the front side? At DH. And where does CDH intersect the back side? At CG. But look at DH and CG. So DH is parallel to CG. Okay? So if the front and back are parallel to each other, see how the side intersects the front and back at DH and CG. So those lines have to be parallel as well. It makes sense because those lines are on those planes which are parallel. Okay? All right, here's theorem 5.2. If two lines in a plane are perpendicular to the same line, okay, so let's stop there and try to visualize this. If two lines in a plane are perpendicular to the same line, so if this line is perpendicular and this line is perpendicular, what can you say about these two lines?
They're never going to intersect.
Yeah, so they are parallel. Then those two lines are parallel to each other. So if this is like line L and this is M and N, if I attach some names to this theorem, if M is parallel to L and N is parallel to L, then if M is perpendicular to L and N is perpendicular to L, then M is parallel to N. Okay? So whenever you don't confuse or don't understand what they're saying in words, try to draw the scenario and then it'll make sense. Okay? So that's theorem 5.2. Theorem 5.3 is pretty similar to that. Here's what theorem 5.3 says. In a plane, if a line is perpendicular to one of two parallel lines, then it has to be perpendicular to the other one. So this is kind of like the same situation, except we're talking about two different lines. So if in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay? Guys, you don't have to memorize this. You just have to kind of follow the logic and see if it makes sense. So let me logically explain using this example here. If line M, or if L, let's look at L, is perpendicular to M, and that M is parallel to N, then L has to be perpendicular to N as well. So it's kind of using the same logic of 5-2 and reordering the ifs and thens and everything like that. So this forms a unique situation that applies to now two theorems. So see how these two parallel lines are perpendicular to that third line, okay? Okay, I'm going to erase this. We're going to start a new page.
Still in lesson 5?
Yep, still on lesson 5. Can I erase 5-3?
Wait, not yet.
Okay.
Oh, wait, I have it. Do you want me to just-
So here's 5-4. I'll leave 5-3 up there for a bit. 5-4. If two lines are perpendicular, then they form congruent adjacent angles. What's congruent mean?
Like.
Yeah, I mean they're the same measure. Yeah. Adjacent. What does adjacent mean? I don't think we've talked about that.
Next to?
Yep. So your adjacent neighbor is the one next to you.
Wait, what's the
If you live in an apartment building, you share the same wall. If you live in a house and you have an adjacent neighbor, you share the same fence line or whatever. Okay? So when you say neighbor, it's not necessarily your adjacent neighbor. I mean, my neighbor across the street or my neighbor down the street, there's still, won't you be my neighbor? I don't know if you will or not. But anyway, the neighbor doesn't have to be next door neighbor. So when we say next door neighbor, that means adjacent. Okay? So in 5-4, so here's the situation. Whenever two lines are perpendicular, so these 1, 2, 3, 4, they form congruent adjacent angles. So 1 is congruent to 4, 4 is congruent to 3, 3 is congruent to 2. Okay? And we know the measurement of those angles. What's the measurement of those angles?
Wouldn't it be 90?
Yep, so those are right angles. Perpendicular lines, and this is another theorem. Perpendicular lines form right angles. Okay, but we're not going to talk about that yet. Here's theorem 5-5. Theorem 5-5 says this. If two lines form congruent adjacent angles, then they are what?
How many more theorems are there?
That's not the answer.
I know
Okay,
the question.
so what did we do? What didn't we just say that? What's the difference between 5-5 and 5-4?
The
Oh,
working is
that's
wrong.
Yeah, it's backwards.
Yeah.
So later we're going to realize that this is called a converse theorem. Converse is just when you switch the if and then. That's it. Okay? So if this is true, then this is true. Well, converse is if that second thing is true, then the first thing is true. Okay? So see how 5-4 and 5-5 are pretty much the same theorem. They're just converse of each other. Okay, here's theorem.
Wait, on Tristan's question, how many theorems are there, like, ish?
And this is the last theorem, and then there's two more theorems, and then we have a postulate, and then we're done.
Are you kidding
That was
me?
Are you kidding me? Look, 5-6 is easy.
Could be worse.
All-
Algebra 2.
Right angles are congruent. That's what theorem 5-6 says. Well, duh, right? Because all right angles are 90 degrees, and 90 degrees are equal to 90 degrees. Yes.
What's the next one? Are we gonna triangulate a triangle?
Not yet. But yeah, you can triangulate a triangle, can't
Just
you?
let it happen. If it's gonna happen, it's gonna happen.
I know you're excited.
Someone else.
Wait, what is that? 3 lines?
That's congruent.
That's all. That's the word all. Sorry.
Oh.
Sure.
Yeah. Is that what you're talking about?
I don't see the A. I
Yeah.
see
It's
a
the
T.
first
Okay, everyone look at example 2. Here's example. Ooh, that looks messy.
one. That I
What looks
don't
messy?
want to see.
I want to see it. What looks messy?
Just don't even worry. Okay, look at this. Example 2. Look at it's a little conjumbled. But in this figure, AB is parallel to DC. So this guy,
Oh my gosh.
AB is parallel to DC.
That doesn't
KL
work.
is perpendicular to DC. Okay? So basically, you can kind of see, most of the time you can use your gut. They look parallel, so they probably are, but make sure it says that it is, just to be safe. Because you might be proving that they're parallel. And PQ is perpendicular to DC as well. So if you go through all these, you could go through these and you can answer these questions. You'll have questions like this in your homework. Since AB and DC are, what is the relationship between KL and AB? Well, use your gut. KL, AB, they look like they're perpendicular. So that's probably the answer. Now on a test, it might say, and tell me why. Well, why? Because it's one of these theorems that we talked about.
Can I just put that in a test?
Yeah, one of these theorems that we talked about. No, but you could say, like, what is the relationship between KL and AB? So you could say, since AB is parallel to DC, then and KL is perpendicular to DC, then KL also has to be perpendicular to AB. Really, that's just theorem 5, either
Is
5.3 or 5.2.
Is there a 5.6?
We just did 5 seconds.
Yep, so it'd be 5, you would say theorem 5.3 is the answer to this. That's why you can say that. But luckily, they're not asking why yet. But it's good to know because when you eventually do a proof, you have to tell me why. You have to tell me why something is true. They're called statements and reasons for those statements. So you can make the statement that yes, KL is perpendicular to AB because it just kind of looks like it. But the reason why is because of theorem 5.3, which says in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay? So that's kind of, if you are struggling with your homework, you can look at that. But for now, you don't have to say why. But a lot of these answers to these problems, even on the tests, are just like, well, use your gut. It looks like they're perpendicular, so yes, they're perpendicular. So don't stress about answering the why question yet, but know that eventually we're going to have to start thinking that way. Okay? All right. So we're on 5. Actually, we're going to postulate 10 first.
Oh.
Is that still less than 5?
Yep, still lesson 5. Postulate 10. Remember, a postulate is something that we've agreed to be true without proof.
So wait,
Okay.
is that an O or an E?
Postulate,
No, it's pestilent.
pestilence.
It looks like an O. I'm sorry.
Okay. Through a point not on a line. Okay, so we're going to start visualizing this as soon as we can. Through a point not on a line. So here's a point. Here's a line.
Oh my gosh.
So there's a point that's not on that line so far. So far, so good. Are you visualizing this? Through a point not on a line. So we're going to draw something through that. There exists exactly one line through the point that is perpendicular to that line. Oh, I'm going to say parallel. Perpendicular is another one. That is parallel to the line. So I'm going to use a different color. So there's only one line that I can draw through this point that is parallel. That's the only line that's parallel to that other line. Okay? Now there's another postulate that says There's only one line that's perpendicular.
Do we have
Cute.
Okay, but this is postulate 10.
what's postulate 11?
Could be that. I don't know yet. I don't have them memorized. Okay?
How many more postulates are there?
Tristan.
I'm lazy. I don't want to keep
I'm
writing.
lazy.
Just ask someone to take a picture of their notes and send it to you.
You don't even have to take a picture of the notes because they're online. You can like look at the video, take screenshots, whatever. If you're really not wanting to take notes, I'm not going to make you.
No, taking notes helps me.
I love it.
Okay, good. All right, so here's example 3. We're just going to walk through this. You don't have to do anything here. Just watch, draw as many lines as possible that are parallel to DE through a point K that is not on the line. Well, there's only one, right? Because that's what postulate 10 says. You can only draw that one line through K that's parallel to DE. That's it. All right? Last theorem, I promised, of this lesson. Theorem 5.7.
This lesson.
Yeah, there's tons of theorems.
How many theorems are there?
Just
in,
stop it.
No, I want to know how many theorems there are in the
There's
whole
a
book.
ton of theorems. You can't.
This is called the transitive
Look through it yourself.
property
Oh, but that's so hard.
of parallel lines. What's transitive mean? Do you guys remember the transitive property of like equality?
No.
I
Yeah.
remember it's like a little transit. If A equals B and B equals C, then A equals C. Do you remember that transitive property of equality? There's also a transitive property of congruence and things like that. If this shape is congruent to that shape, and that shape is congruent to a third shape, then that first shape has to be congruent to the
When
third
did we
shape.
learn this?
So, transitive property of parallel lines, guess what we can say? You could probably figure it out. If one line is parallel to another line and that line is parallel to a third line, then that first one has to be parallel to the third one. Another way to say it is this. If two lines are parallel to the same line, then they're parallel to each other. Okay, so if that line on the floor connected to that wall is parallel to that line, the line that connects the wall to the ceiling, and that line is parallel to, imagine if there's no cutout, this line of that wall in the ceiling, then that means that line, that first line on the floor, would have to be parallel to that. And it is on this plane here, the plane that connects the two corner-ish things. Okay? Are you going to the bathroom?
Yeah.
Okay.
I don't
All
want
right.
to like interrupt.
Yeah, you're good. Thank you for being respectful. Okay? All right, we're good there. Now, I just want to look at this lab with you guys. I am going to refer to this lab, but this is stuff that you've known, that you've learned before. So let's just take a quick look at the lab together. We're not going to spend too much time on it, but here's the deal.
There's in there. I know that sounds like a stupid question, but I actually realize that from last time.
Okay, so perpendicular lines through a point on the line. So in lesson 5 you learned about perpendicular lines. Yep, we just did. The construction lab shows you how to construct a perpendicular line through a given point. This is kind of fascinating stuff. I really like it. So I'm going to just show you how to do this lab. Where's my tools? I've got like tools. Where did I put them? Did you see my vertical? Being impressed? What? Where is it? I've got like this awesome cool tool for drawing circles. This is using a compass, and you might be asked to do this on
I
your
have
test.
one.
Do you have a compass?
Yeah, but it's not like a marker
Joe.
Do you ever stop judging me? No, I didn't think so.
Well, that's a bummer. Okay, so on a compass, I'm gonna have my arm be the compass because I have to be a really big compass. So this is a cool lab that shows you how to make a perpendicular line to another line. So if I drew a line here, okay, if I drew a line there and I put my compass, so pointy end of the compass is my elbow, and then I just made an arc like this, and then I went over here and put that same distance of the compass there. It doesn't really matter, just do that. And then what happens when I connect those intersections? Looky, looky. So if I connect these two lines now, that forms a perpendicular line. Isn't that awesome? So you can do that with the compass. And that's just a perpendicular line, but you can also do that and find the midpoint, and so the perpendicular bisector. So see how we're doing that there, boom, boom. Okay. All right, so it's perpendicular to that, but then you can also find like the halfway between the two by using the perpendicular bisector. So if I had a line segment, like this line segment right here, AB, okay, if I put my compass there, and then I put my end point and my pointy end on the B, and create those arcs, and then I put the pointy end on A, then it makes two arcs like that, and then if I connect those two, that forms what we call a perpendicular bisector. So that is the midpoint. So it's very important to keep that compass the same distance apart, right? And then you can create that. So that's pretty much lab 2. This is stuff that we'll refer to in future lessons, so it's important to just mention it, okay? I don't know if you'll have to do that on a test, but it is fun if you ever want to do it.
Flack math, give me some math and I'll give you some flack. Flack math.